This is a solution to question number 5b from your final exam. In this problem, you were asked to approximate f of 1 using Euler's method. And so when you do this, however you want to do it, you just have to make sure that when you come about this approximation that you show all your calculations. This year, when I taught this to you, I proposed the 4-column approach. So you see here those 4 columns. The first 2 columns are for both your x and y coordinates of your point. Third column is your slope calculation, and you get that because that is your original differential equation there. And the last column, well, that's going to be a column where we construct a tangent line equation. And the basic idea of Euler's method is that you are sort of using tangent lines to help with your approximations of the particular function. So, first thing we do is we're given the point 0 and -1, and from that we want to construct a tangent line equation at that particular point. So using 0 and -1, and the differential equation, we solve for the slope value at that point, and for our tangent line equation, the slope in particular is just going to be equal to 0. So that makes our tangent line equation y plus 1 equal to 0, x minus 0. Now, the next particular x value, or next particular line that we have, well, we get that first by identifying the next x value. They have to always tell you in the problem how to proceed. So we want to approximate the function at x equals to 1, and we're supposed to get there by using 2 steps of equal size. So that would mean that the next x value, where we would do this process, would be at x equals to 1/2, and then to find the y value at that particular point, we use a tangent line that we just constructed over here to help find the approximate y value at x equals to 1/2. So, plug it in, we would have y plus 1 is equal to 0, parentheses 1/2 minus 0. And solving for y in that particular equation, we would have that y would be equal to -1. Now that we have a second point, we repeat this process, construct another tangent line, and then use that tangent line to continue this process. So the next thing we would do is solve for the slope of this new tangent line, and given a new point 1/2 comma -1, we would have the slope would equal 1/2 times -1 minus 1/2, which simplified would give us -1. So our tangent line equation at this point with slope of -1 would end up being y plus 1 is equal to -1 times x minus 1/2. And then repeating this process, the next x value we would have, well, our delta x is going to be 1/2 because we're using 2 steps of equal size. So the next x value would be at x equals to 1. And we would get the y value at x equals to 1 by using our newly constructed tangent line equation. So we would have y plus 1 is equal to -1 times 1 minus 1/2. And then solving for y in this new tangent line equation, we would have that y plus 1 is equal to -1 times 1/2, making y plus 1 equaling -1/2, so y would equal -3/2. So our approximation of f of 1 using Euler's method would be that f of 1 is approximately equal to -3/2.